So we have discovered what log graphs look like. We know the difference between when our base is greater than 1 and when our base is between 0 and 1, but not equaling 0 and not equaling 1. We just went over domain, so that's going to help me with my vertical asymptotes. And now let's start shifting these graphs a little bit. So my vertical shift, when I have a log, whether it's a common log, a natural log, and I just didn't want to make this even bigger, but any log with any base, and we add something to the end, this shifts up k units. When I have a log and I subtract k, it goes down k units. So outside, same. Plus is up, minus is down. Horizontal shifts happen within that log, and that's like these right here. So when I have an inside my log and I'm adding an h, we think of pluses to the right, inside opposite though, this one's going to go to the left. And then when I subtract h, we think of it as going to the left towards the negative numbers, but this one goes to the right. Okay, so sorry this is on the page before. Let's turn the page though, and let's kind of use these. Hopefully we've been using transformations enough in this class that we don't really need to rely on this table too much. I apologize if you do, just kind of flip back and forth. The best I could do on the notes. But here we go. So example 4, for the following function, briefly describe how the graph will be obtained from the graph of a basic logarithmic function. Then graph the function and state the domain and the vertical asymptote. So first, what is the base of this? That is a log with a base of 5. So if I have a log with a base of 5, and now I have log base 5 of x plus 3, what is my horizontal and or vertical shift now? That plus 3 inside parentheses moves it to the left. So this will be left 3 units. Oops, I don't know what I'm doing. Okay. So what is the domain? I'm going to take what's in parentheses and set it to be greater than 0. So subtract your 3 over and we get x must be greater than -3. An interval notation, that is -3 to infinity. So where is the vertical asymptote? The vertical asymptote is where this domain starts. So we're at x equals -3. Now we still don't know how to put logs with a different base in our calculator yet. I think we learn that next lesson. So I went ahead and put these in our calculator for us. Here is log base 5 of x, and here's log base 5 of x plus 3. So the first graph is going to be without a shift. The second one will be with a shift. Let's go zoom 6 so we can see our graphs. That was the first one, and then there's the second one there. And actually, I'm going to go zoom decimal right here, number 4. And that makes it a little bit more clear. One thing I want you guys to notice is that it looks almost more like a square root where it starts right here. And it's just because our graphing calculator can only do so much, right? And so it can't keep going without hitting or going over that vertical asymptote. So we need to know that that's going to continue down and go forever. We need to know that that continues down and goes forever. So be aware of that when you see that graph. But you can see that that graph has been shifted over, which then shifts that vertical asymptote as well. Same question on number 5. What is my base? My base is 10. This is a common log. And what is the horizontal and or vertical shift? So inside the log with a minus means it shifts to the right. So we're going right 2. And plus on the outside means up. So up 3. So let's just take a minute and graph because it wants to know how the graph will be obtained from the graph of the basic one, right? So if we clear these out, if I put log of x, because we can graph common and natural logs in our graph, and then I do log of x minus 2 plus 3. Here's my first log, and here's my second one, moving to the right and up. So what is the domain? I'm going to take what's in parentheses here, set that to be greater than 0. So first thing I do is add that 2 over. And actually, that's the only thing I do, right? So now this, an interval notation, would be 2 to infinity. So where's that vertical asymptote? It's where this domain starts at x equals 2. Okay, let's keep going. Example 6. Example 6 says use the function f of x equals the natural log of x minus 1 to answer part A through J. So what is the base of our function? Well, if we have a natural log, that's a base of e. So what is the horizontal and or vertical shift? That minus 1 inside means it's going to the right. So this is going to the right 1. Okay, now to kind of help you, these right here, all we need to be able to graph, right? And I don't know why this one doesn't have a star 2. But in my math lab, if you hover over your tools, just like with exponentials, exponential and log are very similar as far as like the button goes. So hover over it, one will say exponential and then the other one will say logarithmic. So if you want that one, when you can identify the base and which way it shifts, it does the rest of it for you. So what is the domain? I'm going to take what's inside, set that to be greater than 0. So we get x must be greater than 1. So an interval notation, that's 1 to infinity. What is the range? Well, we can do this one of 2 ways. If I graph this, I can find the range. We have natural log x minus 1, and here is my graph. So remember, it looks like it starts right here, right? It looks like a square root, but it's going to keep going down forever. So as we go from the bottom to the top, we're going from negative infinity to infinity. So you can either use the graph, or in a previous video, we went over how the range of a log will always equal all real numbers. Where is the vertical asymptote at? It starts right here, at x equals 1, wherever that range is. Now find the inverse. Here's my instructions to find the inverse. The first thing I'm going to do is replace f of x with y. So I have y equals the natural log of x minus 1. I need to now interchange my x and my y. So this becomes x equals the natural log of y minus 1. And now we need to solve for y. Well, I don't have a way to solve for y when it is inside my log. So what are we going to do? We're going to rewrite this as an exponent. Natural log is with a base of e. So we're going to go base to the other side of the equals. So this is e to the x equals what's inside my log, y minus 1. Now I can solve this for y. Get your 1 over by adding. And so we'll have e to the x equals e to the x plus 1 equals y. And then my last step is to replace y with your inverse notation. So the inverse of x equals e to the x plus 1. So what is the base of my inverse? This is an exponential with a base of e. Your base of your function and the base of your inverse will always be the same. We found that out when we were discovering our graphs of logs. Now, what is the horizontal and vertical shift of my inverse when it is outside, even though these all show logs, when it is outside of that function, it goes up. So up 1. And so if you notice, we went left, or we went right 1. Now we're going up 1. We're going in opposite directions. What is the domain of my inverse and what's the range of my inverse? Well, if you want, you can graph this and use your domain, or use the graph to find the domain and range. But the domain is going to be the exact same thing as the range of your function. And that should make sense because all exponentials have a domain of all real numbers. So then your range is going to match your domain right here of 1 to infinity. And again, that should make sense because this one has a horizontal asymptote. And if you are shifting this up 1, it shifts that range from 0 to infinity to 1 to infinity. Example 7. Same questions. My f of x is wrote a little different. If you want to rewrite that, you can. This would be the same as f of x equals the natural log of x. Because there's something behind it, we're going to put x in parentheses and then minus 2. I think they write it this way because if you don't have parentheses here, you don't know if that 2 is within that log or out of that log. So if you write it this way here, it avoids confusion. But you can rewrite it the same way if you put x in parentheses to say only x belongs to that log, that minus 2 is outside of that log. So what is your base here? Either way, we have a base of e because they're both natural logs. What is our horizontal and or vertical shift? Well, if I have a minus 2 on the outside, minus means down. So this is going to shift down 2 units. What is the domain? To find the domain, you take what's in parentheses, this one, x, and set it to be greater than 0. So that means my domain is from 0 to infinity. What is the range? Your range of any log is all real numbers. And where's your vertical asymptote? It's where your domain starts. So at x equals 0. Should make sense that that domain and that vertical asymptote are unchanged because we're going up or down. So it's not changing where that vertical asymptote is. So now let's find the inverse. And I'm going to use this version here to find my inverse. Now let's go ahead and use this one. We'll use this one to find our inverse. So I'm going to rewrite my first step is to replace your function with y. So I'm going to rewrite this as y equals. Second step is to interchange our x and y. Now we need to solve for y. Before I rewrite this, I've got to move this 2 over. I need to get my log isolated. So I'm going to add that over. And now I can rewrite. We're going to go base to the other side of the equals. My base here is e. On the other side of the equals is x plus 2. So we have e to the x plus 2. And that's going to equal what's inside my log of y. So now I have y solved for. Replace your y with your inverse notation. So the inverse of x equals e to the x plus 2. So these next four have to do with our inverse function. What is the base of this inverse? It is still e. What is the horizontal and or vertical shift? Okay, again, these are all logs that behaves the same way. Because this x plus 2 is in the exponent position, it means it's within that function. So plus 2 makes it go to the left 2. What is the domain? Well, your domain of any exponential is all real numbers. You can also graph it to find that, or we know that the domain of the function is the same as the range of, or the domain of your inverse is the same as the range of your function. And then what is the range? The range is the same as the domain. So it will be 0 to infinity. Which this one should make sense as well. These have horizontal asymptotes. So if you're moving it left and right, it doesn't change that horizontal asymptote in any way. All right, and then on our last example here, example 8, it says use the function f of x to answer parts, again, a through j. So what is the base of this function? This is e. What is the horizontal and or vertical shift? This plus 3 is inside. Inside's opposite. So we think of plus to the right. This goes to the left 3. Outside same. This plus 2 is up 2. What is the domain? It is all real numbers. Why? They're trying to trick us, and they have switched from log functions to now exponentials. Right? This is an exponential. Logs have a log in them, either natural log, common log, or some version of a log with a different base. So my domain is all real numbers. So what is my range here? Well, if I'm going up 2, it's going to change that range from 2 to infinity. So let's look at that real quick. If I graph this, e to the x plus 3 plus 2. There's my graph. And if I go to my table, you can see it's getting closer and closer to 2, where it's eventually going to round it to 2 because it's getting really close, but it's not actually 2. So they took that horizontal asymptote at 0 and shifted it up 2, since we're shifting our graph up 2. So that answers this one. Where's my horizontal asymptote? It's at y equals 2. Now let's find the inverse. So first thing I'm going to do is replace my f of x with y. So this is y equals e to the x plus 3 plus 2. Now I need to interchange my x and y. And now solve for y. If you haven't been pausing and trying to do anything on your own, I highly, well, even if you have, it doesn't matter. Either way, pause and try to finish this problem and solve for y or get to your inverse. Yeah, I hope you had time to pause and try to finish this on your own. We need to solve for y. So before I can do anything, I need to isolate this exponential portion. So we need to subtract our 2 over first. Now rewrite it. I have no way of solving for y in an exponent position, so let's see if changing it to a log helps this. Base to the other side of the equals. A log with a base of e is your natural log. So we have natural log of x minus 2. And this is going to equal what's left over, our exponent is y plus 3. We're not done solving for y. I'm going to move this 3 by subtracting. We have the natural log of x minus 2 minus 3 equals y. And then our last step is to replace y with our inverse notation. So the inverse of x equals the natural log of x minus 2 minus 3. Okay, so now based off of this function, what is my base? Well, natural log has a base of e. Minus 2, we think of going to the left. This one's going to go to the right, 2. Outside same, minus means down, 3. What's the domain? You can do it one of 2 ways, maybe 3 ways. You can use the graph. You can take what's in parentheses and set it to be greater than 0, or the domain will be the same as this range, which is what we get if we set this to be greater than 0, add that 2, we get that x must be greater than 2. And then your range, for all logs, your range is all real numbers, or your range will be the same as the domain here. Those should be equal.